Welcome to American Northwest Aviation. I'm Danny. Today this video is for pilots who already have a certificate, at least a private, and are looking forward to perhaps getting an Airbus type rating someday on the A320 Neo. We are going to take off, fly to about 2,000 feet, which will be about 1,800 AGL, make left traffic pattern for the same runway we took off on in ABBOTSFORD, Canada. ABBOTSFORD is just southeast of Vancouver, Canada, and northwest of Seattle by about 3 hours driving time. We will assume you already know how to use Microsoft Flight Simulator 2020. We also will assume that you have a joystick, a cyborg, or something like that. We will assume that you have the fly-by-wire mod. One thing we will show you today is how to fix an issue that occurred just recently to me, and that is that the joystick left and right controls was also controlling the rudder and the nose wheel steering all of a sudden. So that'll be the first thing that we address in this video. In a flight simulator, you should have the mentality that you train like you fly like you train. In other words, don't have the attitude that we're just in a flight simulator, so it really doesn't matter about our disciplines. For example, checklists, limitations, so on and so forth. But today we'll acknowledge that that is the important attitude to have. That being said, we have the presence of mind that that's what needs to be done in normal circumstances, but for the purposes of expediting, we're going to deliberately not use the checklist today, just use some flows, and we're also not going to worry about the limitations or certain disciplines in the air, because the main point of this video is to take off, fly the pattern, and land the aircraft with the minimal amount of instrument aid. You might find this video on American Northwest Magazine, our sister channel, and if that's the case, go to the description. We'll have a link that goes directly to American Northwest Aviation's YouTube channel so that you can see all of our aviation content. And if you are on our American Northwest Aviation YouTube channel, please check the link and click on the link that takes you to American Northwest Magazine for more variety. Please subscribe to this channel and to American Northwest Magazine if you're over there. And please like, share, click on the notification bell, and comment on where you're watching from and what kind of videos you'd like to see from us in the future. We have playlists that you can find on American Northwest Magazine, and specifically one for aviation videos, as well as many other subjects. So this message came up, and this alerted me that we needed to go into the settings and change them. Because the last time I flew this simulator, the nose wheel steering was being affected adversely by something I wasn't quite sure, and so now I've discovered that this was the problem. There's some assistance that the flight simulator software gives you if you're inexperienced. So we'll go into the settings and change the settings that give us assistance. We'll get rid of those. Meanwhile, we're doing a pre-flight inspection here, doing something very brief, just a flow. Got more than 8,000 kilograms, which is more than, say, 3,000 pounds of fuel. Our thrust reversers are, our power lever is in the thrust reverse range, and we need to take that out there. We did that. Checking instruments. All the doors are closed. Of course, we check that right after, just before engine start. Checking engine parameters. Checking our bleed air system. cabin pressure system, and our electrical system. It's a mystery why the batteries aren't charging right now. We'd normally see a line from DC bat bus over to the batteries. If I am wrong, somebody correct me in the comments. APU is shut down. Door was closed on the APU panel. Wheel brakes look good. Flight controls, we'll go ahead and check them. Ailerons and spoilerons look good. Elevator looks good. And left rudder and right rudder, which I'm activating with the buttons that we were pressing when you saw our cyborg controller earlier in the video. Again, checking instruments. Heading lines up with the runway 25, and the emergency gyro is looking good, otherwise known as ISIS. We got flaps 1 and slats. You can see the white band that indicates the speed brakes are armed for abort, and the cabin door is locked. Parking brakes coming off. Okay, now we're going to go ahead and go into the controls and the settings and change them so this message doesn't appear, and we know we can rely on our nose wheel steering not to be influenced by our aileron inputs. So we'll go into assistance options, and we're going to get rid of all of these. Somehow these came on and I didn't know it. Must have been during an update. So get rid of all of these, as I do. That way my nose wheel steering and rudder will be controlled by those buttons I showed you on my cyborg. By the way, the central one centers the nose automatically for you. And we'll save these options, save the changes, and go back down to the bottom left and resume. We're not going to be setting our guidance panel at all. We're just going to fly by the seat of our pants, get a good feeling for the Airbus. We've done our cigar check, controls, instruments, gas, attitudes. By the way, there's a video following the flight portion of this. That's a tutorial on our auto throttle, or excuse me, auto thrust. Anyway, and auto trim. We didn't do a takeoff card. We're going to rotate about 130 knots and climb out at about 180 and pull our power back to maintain 2,000 at around 2,000 feet MSL, which is about 1,800 AGL. We're going to leave the flaps down and the slats down as long as we stay in the pattern. Just slats and flaps 1. On final, we'll go to full flaps. fly around 140 knots final approach speed. And ignore ATC. We're not going to deal with ATC together, or today. I was saying earlier that that you should stay on and watch the tutorial about the Autothrust, thrust levers, pitch trim, and auto trim system. I did switch my display over to rows rather than arc so I can determine 90-degree angles since I can't look out the window to see where the runway is. Off to the right is the United States and the state of Washington and Sumas, where the border crossing is between ABBOTSFORD and Sumas. Pretty much straight ahead, just off to the right. It's Mount Baker, you can see at about, I think that's 1 o'clock. I'm not able to see the display right now very clearly. By the way, I'm narrating after the flight. I don't like narrating while I'm flying. This is pretty much the border right under us at Sumas and ABBOTSFORD. And we'll be turning final for runway 25 real shortly. And we're turning final now. Once we have the airport in sight, we'll go flaps to the full position. Which on my simulator I hit F8 to get full flaps. And I got the runway in sight coming about 11:30 now. Looking for about 140 knots. I'm not using a glide slope or anything. I think you should just fly a pattern with this airplane over and over until you get comfortable flying it visually. It is more difficult than the real airplane, as has been the case with every airplane with my experience. Want to land within 500 feet after the touchdown zone markers or the aiming points, and within 1,000 feet before them.
Pull up, pull up.
50, 40, 30, A320, retard.
Yeah, you can see the auto spoilers extended with all those little arrows on the bottom display in the center. Okay, we're not going to do any after takeoff checklists or anything. We're just going to pull off the runway, and then we'll go into the video about the pitch trim system, the auto pitch trim system, and the power levers, and the auto thrust system. If you have any questions about Flight Sim 2020 or the Airbus A320, I'm not an expert on either, but I am learning myself, and I will try to find the answers if you can't find them. As well as if you need to set up fly-by-wire. It's a download that goes into the community folder in your Flight Sim 2020 program. But they've got it streamlined very nicely. You just download it or install it and do an occasional update, and you're golden. And just about every button works on it. If you don't do that, a lot of the functionality of the systems and buttons you won't have. I'm going to show you the controller I'm using, the flight controls. I already showed you the left rudder and left nose wheel steering, centering, and right rudder. So that center button will center the nose and center the rudder. That was left aileron, right aileron up and down, and that is my power levers, both 1 and 2, forward and back. In the next segment of this video, we're going to do a tutorial on the Airbus A320neo's auto trim system and pitch trim, and that's the auto pitch trim system that we'll be talking about, as well as the power levers and the auto thrust system. This video is for pilots that have a private pilot rating already, or maybe they're getting close to getting their private pilot rating, and perhaps a pilot that has already everything through MEI and multi-engine ATP. This is a course for the Airbus A320neo, and a lot of this pertains to the pre-neo aircraft as well, or the legacy A320s. So what we're going to cover today is the power levers and the pitch trim auto trim system. So generally speaking, without getting into all the details right away, the power levers are controlled manually. That's the only way they can be controlled. The auto thrust system does not move the power levers while it is adjusting the N1 when you have auto throttles engaged, or auto thrust. The pitch trim system, unlike any aircraft I've flown before, is completely auto. And basically the pitch of the aircraft will stay where it is without you having to manipulate a pitch trim wheel, electrically or manually. There is a pitch trim wheel. We'll talk about that in another session, but Today, just want you to know you do not need to use the pitch trim. The nose will stay where you leave it in most cases. There are some cases that we'll discuss when the pitch trim will change without you moving it. But for today, the pitch trim will stay where you move it, or where you've already moved it. And just to review, the auto throttles, or excuse me, the power levers will not be moved by the auto thrust system. So here are the power levers in the Airbus A320neo. As you move them, they click in and out of these detents. The first one here is FLX MCT, which stands for flex power and max continuous thrust, and then CL for climb. And if it's in this range, the auto thrust will, if it's engaged, as long as the power levers are in this range, the auto thrust will control N1 for you. N1 is how we measure the power in this aircraft. That's the speed of the fan. So this is the lowest thrust setting. And of course back here you have reversed thrust. You'd have to be in the actual aircraft to feel how to get over into the detent, into the reverse thrust. As you can see, there is a range and there is full reverse thrust. We will put this in the description, this address. And as you can see, there are many subjects here that it discusses. For example, the flaps, the cockpit door seal panel, ATC TCAS panel. We'll start with the pitch trim wheel. The A320 has a feature called auto trim, which makes it unnecessary to hold the side stick or use the trim wheel for holding the current pitch. The auto trim is using a load factor demand mode, which means in level flight the system maintains 1G and no input is needed from the pilots to correct for speed, turns, or configuration. In other words, if you put flaps in, the pitch will remain the same. The system is always active, even when the autopilot is off. In normal law, the laws which we'll discuss later and we'll give you some resources for, which means under normal circumstances with a fully functional aircraft. Nevertheless, the pitch trim wheels in the cockpit provide mechanical control of the trimmable horizontal stabilizer and have priority over electrical control. The autopilot is disconnected when a pilot uses the trim wheel during flight. Note, pilot's use of the pitch trim wheel does not disconnect the ELACs to make sure that the computers maintain synchronized with the manual selected position. So, of course, this is what we're using instead of a control column like a steering wheel. And of course, on the right side, you have one over here. Description for the thrust lever panel. The A320 has so-called CYXX, which stand for Full Authority Digital Engine Control, and is responsible to ensure the engine is performing at maximum efficiency for a given condition. As one CYXX dedicated to each engine controls the engine's operation, the pilots, or the FMGS, can set the thrust. The pilot uses the thrust levers when in manual mode, and the FMGS sets the thrust in auto mode, A/THR, aka takeoff thrust. And again, the power levers will not move when the FMGS sets the thrust in automatic mode, or auto thrust. The levers in the A320 can only be moved manually and are not moved by an auto throttle system as it does in Boeing aircraft. The CYXX controls and limits thrust not to exceed the limit set via the thrust lever position in both manual and automatic modes. The CYXX receives the current thrust lever position and computes the thrust rating limit and the N1 for that thrust lever angle, TLA. If the thrust lever is between two detents, the CYXX will select the rating limit of the higher detent. In other words, if it's between CL, which is climb, and MCT, which is max continuous thrust, in that scenario, it will default to MCT. So if the power levers are set right here, it'll go to MCT power setting. Manual thrust control. When the auto thrust mode is not armed or not active, levers in wrong position, the engines are in normal mode. The thrust lever position controls thrust for the corresponding engine in this case. By moving the thrust lever, the pilot can set the thrust level, which corresponds to an N1 between the idle and toga positions. So this is idle, and this is the toga position. Takeoff, GA, go around, toga. FLX MCT detent. We just saw that. On the ground, the engine will produce the maximum continuous thrust, MCT, if the crew did not set a valid flex takeoff temperature. It needs to be higher than the current total air temperature to have an effect. You would do that in the MCDU, which is the button face of the FMS, if you will. But that's not actually the FMS, that's an MCDU. It's just an input panel. After takeoff with a flex thrust, the pilot can, by moving the thrust lever to toga or CL for climb, choose MCT thrust. It is not possible to go back to flex thrust. Note, setting the thrust lever out of FLX MCT detent without reaching toga or CL, we'll just call it climb from now on, detent has no effect. Max takeoff thrust can always be achieved by pushing the thrust lever all the way forward. Automatic thrust control. In auto thrust mode, the FMGC computes the thrust. Thrust is limited by the thrust lever position, except when in alpha floor mode, which we'll discuss in the future. Autothrust instinctive disconnect push button. Each thrust lever has a so-called autothrust instinctive disconnect push button in red. Pressing it disconnects the auto throttle. This button here. If the flight crew pushes and holds one instinctive disconnect push button for more than 15 seconds, the auto throttle system is disconnected for the remainder of the flight. All auto thrust functions include alpha floor. Start over again. All auto thrust functions, including alpha floor, are lost, and they can be recovered only at the next FMGC power-up. That concludes this session on the Airbus A320neo. Please subscribe, like, share, and comment, and click on the notification bell. And in the comments, let us know what kind of video you would like to see in the future. Thank you for watching.